All right, this is part 3 of the video series for review for test 2. We're looking at finding the exact measure of angles, and the situation that we have here is that we have an inverse function and a function that's the original, and they're being composed with each other. Typically what we learned is that when you have a domain from the original, it maps to the range, and then this range becomes the domain of the inverse and it maps back to the domain. So you should just have a back and forth between the two functions. Now the problem is that the inverse functions have very specific domains that we have to work within. So sine of 5 pi over 6, which is an angle, is not in the correct range that we need our inverse function to have. So remember, sine is defined on the inverse sine is defined on negative pi over 2 to pi over 2. So since 5 pi over 6 is not in that range, we need to think about where that is and what would be a similar sign located next to that. So 5 pi over 6 is over here in quad 2, and it has a positive value. So we need to know out of the two possible quadrants, which is negative pi over 2 and pi over 2, which one is the correct one to match with 5 pi over 6. So since sine is positive, it has to just be pi over 6. So the answer to this one is that the sine value that's in the correct domain that we need for the inverse that maps to the same ratio for positive sine here is going to be for pi over 6. Okay, and then let's look at our next one, cosine inverse of cosine of 7 pi over 4. When you're dealing with cosine inverse, it has a different domain. Its domain is 0 to pi. So 7 pi over 4 is not in that range as well. So to be able to talk about doing the inverse and the original together, we need to know what angle would be a better match and have the same cosine ratio. So 7 pi over 4 is down here in quad 4, and this is where cosine is positive. The only two quadrants that we have available to us are 0 to pi, so that's these top two, and cosine is also positive up here. So this would be at pi over 4, since that would have to also be a 45-degree angle. So pi over 4. And then for tangent, when you're doing the inverse function with tangent, you want to make sure that you are between negative pi over 2 to pi over 2. Sine and tangent both have the same inverse function domain. And again, 4 pi over 3 is not in the correct range. In fact, 4 pi over 3 is down here in quad 3. So tangent only makes sense when we're in quads 1 and 2 when you're talking about the inverse function. So that means that we need, if tan is positive, remember all science teachers are crazy, so tan is positive down here, we need another place where tan is positive. So that's going to be at the match to this one, which would also be a pi over 3. So this one would map to pi over 3. So we're mapping to, when we do these inverse and original functions, if it doesn't already fall in the domain that we need it to, we're going to map to the other place on the unit circle where you would get the same tangent value for your ratio, because usually that will sit in the restricted domain. Okay, so I'm going to scroll down because I believe these aren't numbered exactly right. So we're looking at 30 next. So 30 has two different problems here. They have the tan inverse that they've given us, but they don't have a tan on the outside, so this is not going to work the way we just did the last ones. The way we can do that is only if they're the same, but one's the inverse and one's not. So this is two different trig functions. But what we can do is we can talk about what does this tell us. So we're kind of working on the inside and then working our way out. So tan inverse of negative square root of 3. First of all, with tan, if it's inverse, it has to be any real number, so we're good there. So at least that makes sense. With cosine and sine, you have to be between negative 1 and 1 for you to have the inverse on the inside part. So what we're looking at is we're saying what theta has a tan ratio. I'm going to write it as negative square root of 3 over 1. Another way of thinking of that is that that's been reduced, and maybe this was negative square root of 3 over 2 over 1/2. So that gives us, remember, a 30, 60, 90. So let's think about that. Okay, so since it's tan inverse, It has to be either in quad 1 or 4, because that's where the inverse makes sense. And then since this is a negative square root of 3 over a positive 1, or over the 2's on both of those, that means that tan is negative. So we're actually down here in quad 4. Now, we're never going to actually figure out what that angle is, even though I know I can find it. That's not the point of the exercise. The point of the exercise is to figure out what theta this is so that we can then find sine of that triangle. Okay, so when we look at this, that means that this is, remember, tangent is opposite over hypotenuse, or excuse me, over adjacent. Sorry, it's very late. Opposite over adjacent. So that means that the opposite is the negative square root of 3 over 2, since this is a negative y value. This is the 1/2, and this is the 1. And all I care about, I don't care about what this actual angle is. I want to know what is sine of my theta now that I correctly have it in the correct quadrant based off of the inside part. So sine of this would be opposite over just height. So that's just negative square root of 3 over 2. Okay, so let's try another one. So this says cosine of sine inverse of 1/2. Again, this is not one where they're the exact same, so we're going to have to do some kind of triangle to figure out where we're at. So again, with sine, as long as that's between negative 1 to 1 when you're dealing with the inverse on the inside part, you're good to go. So we need to think about where sine is defined for inverses, and that's again in negative pi over 2 to pi over 2. And since this is, so we're saying what theta has a sine of 1/2 in our restricted domain. And since it's 1/2, sine being 1/2 is in a positive light. So that means that sine's in the first quadrant, not the negative sign down here. So sine would be, remember, opposite over height. So that means this is square root of 3 over 2. So we don't care what angle that actually is. We just want to know what is cosine now of that theta. So cosine, remember, is adjacent over height. So that's square root of 3 over 2. Okay. And then let's look at this next one. This says tan of cosine inverse of negative square root of 2 over 2. Remember that cosine inverse is defined on 1 and 2 from 0 to pi. And for cosine to be negative square root of 2 over 2, that means we're over here. We have to be in quad 2. So that would be negative square root of 2 over 2. Sorry, this is the positive one. Negative square root of 2 over 2 over 1, which means this is also square root of 2 over 2. So that's the 45, 45, 90. But again, all we care about is what is tan of that now theta. So that would be square root of 2 over 2 over negative square root of 2 over 2. So this is negative 1. Okay. Moving back up to the page before, we still had 33, 34, and 35 before we can move on to the last problem set. This says find the exact value of these expressions. So this is the same process, except these are not going to come out as nice triangles. Most people do okay with the ones that I just did because they're like, oh, those are just 30, 60, 90, and 45, 45, 90, and they can figure them out without knowing the process. This is where you have to actually think. So this says cosine inverse is 7 over 11. So if we draw that picture, so this is going to help us locate our theta. So the inverse, and again, this has to be between negative 1 to 1 to be able to do cosine or sine inverse inside. So that's good because that's less than 1 and greater than negative 1. So we are in, cosine, remember, is in quads 1 and 2 for the inverse function. And since it's positive, it's going to be quad 1. Cosine is adjacent over height. So now we have to actually find that y value. So this is 7 squared plus y squared equals 11 squared. That's 49 plus y squared equals 121. Subtract the 49. That's going to be 272. Take the square root of that, and it's going to be positive since it is in the quad 1. And square root of 72 is going to be square root of 9 times square root of 8. Actually, that's not the biggest we can do. The biggest perfect square that goes into 72 is 36. So that's going to be 6 on the square root of 2. So that's this side of that triangle. Okay, so once you've done that, that's now your theta. That's where theta is correctly supposed to be drawn. In quad 1, because the inverse says the cosine is got a positive ratio, and remember cosine inverse can only be in quad 1 or 2 when they use that function. So the next piece is we just want to know what is cosecant of theta, and a better way to find that might be to find sine of theta first and then just flip it. So sine of theta is 6 square root of 2 over 11. So if we flip that, that would be 11 over 6 square root of 2. Rationalize the square root of 2. So that is 11 square root of 2 over 12. So that is my cosecant of that theta. Let's do another one. Let's do 34. We have tan inverse inside with a negative 6 over 17. And the outside function is a secant. So we're going to focus in on the inside first. And because it's the inverse function, tangent, remember, can be any real number inside. That's the only one that doesn't have a restriction when you're doing with the inverse. So we're looking at tan, which is defined, remember, in quads 1 and 4 when you're talking about the inverse. And it's negative in the fourth quadrant. And remember that theta then would be negative 6 and 17, because opposite over adjacent. And so we use that to find our other piece of our triangle, equals h squared, whatever you want to call that. So this is 36 plus, I have no idea, is that 289? Yes, 289. And we add that together to the 36. That's 325. We want to take a square root of that. And it's going to be positive because hypotenuse is always positive. 25 definitely goes into that. Let's see if anything bigger does. So that's going to be 5 on the square root of 13. So 5 square root of 13. Now, once we have the triangle labeled, we can now find the secant of that theta, which is, remember, the cosine flipped. So cosine, remember, is adjacent over hype, which is good for us. We don't need to rationalize this because once we flip it, the square root will be on the top. So 5 square root of 13 over 17. All right, and then the last one of this type is we have cotangent of inverse sine of 13 over 21. Double check when you have an inverse that's a sine or a cosine that this is between negative 1 to 1, so we're good there. And then we're going to draw a triangle. And sine, remember, is defined in, again, quadrant 1 and quadrant 4 when you're talking about the inverse function. And since it's positive, it's going to be in quad 1 for sine, and that's 13 and 21. So we're looking for the x value here. So x squared plus 13 squared equals 21 squared. So that's x squared plus 169 equals 21 squared is 441. Subtract the 169. That's 272. And I wonder if 36 goes into that. No. 272 divided by 4. 272 maybe divided by 16, since I think that might be bigger. Yeah, so it is 16 times 17, or 4 on the square root of 17. Okay, so once we have our triangle labeled, we want to do cotangent of theta here. And I would just do tangent first again and then flip it. So tangent is opposite over adjacent. But since cotangent is what we want, we just need to flip that. So there we go. So that's the last of that type. The last three we have are solving equations. And we don't know if they're factorable or not, so we're going to try to see if they are. If they're not, we're going to end up doing quadratic formula to help us solve for the sine theta part, and then we'll use, remember, what we know about how the quadrants work to help us find all the solutions. So let's look at this first one. I'm just going to double check to see if it's factorable. So if I do 21 times the 3, the negative 3, That's 63. Factors of 63, well, I know 3 goes into it 21 times. That doesn't make 10. Divided by 4 doesn't work. 9 goes into it, 9 and 7. That also doesn't make 10. So it doesn't look like this one is factorable. And even if you don't want to check, you could just jump straight into quadratic formula. So since x is kind of like sine theta, we're going to be doing sine theta equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so this would be sine theta equals 10 plus or minus the square root of 100, and then this is going to end up being a plus because you have two negatives multiplied together in that second part, plus 252 all over 42. So this is 10 plus or minus the square root of 352 all over 42. We want to see if 352 has any perfect squares that goes into it. 4 definitely goes in. Let's see if 16 goes in. Yeah, 16 will work. So that is 4 on the square root of 22. So let's rewrite this. So sine theta, I'm going to write my two versions. 10 plus 4 square root of 22 over 42, I'll reduce that. Or sine theta equals 10 minus 4 square root of 22 over 42. Okay, and if I reduce those, I divide everything by 2. This would be 5 plus 2 square root of 22. Remember, that's in the radical, so it doesn't get divided, over 21. And sine theta equals 5 minus 2 square root of 22 over 21. Now, the big thing about this is we don't have any triangle that has those as its ratios that we know off the top of our head. It's definitely not 30, 60, 90 or 45, 45, 90. So we're going to turn these into decimals. First, there's two reasons for this, because we're going to have to use the inverse sine function to solve this. Now, using the inverse sine function means that we have to be able to say this ratio has to be between -1 and 1. Sine only fluctuates between -1 and 1. So if this is not between -1 and 1, this gives us no solutions. If it is between -1 and 1, it will give us two solutions usually on the graph, and I'll show you how to find that. So let's figure out what 5 plus 2 times square root of 22, that's our top. Go ahead and hit enter for me because mine's weird, divided by 21. So that's about 0.685. So this one is definitely, I'm checking between to see if they're between -1 to 1. So this one's good. Let's check the other one too before we go any further. 5 minus 2 times the square root of 22. Oop, that's too many 2's. And then hit enter so it'll divide correctly. Divided by 21 is -2.09. So this one is definitely also between -1 to 1. Okay, so that means that we can say theta is sine inverse of all of this. And theta is sine inverse of all of this one. And give me a second, I'm going to pause this and I'm trying to give myself some more room to write. All right, so we're going to be looking at using our calculator to do the inverse here. So let's start off with this first one. So 5 plus 2 times the square root of 22 equals divided by 21. Notice I didn't clear anything. And then remember, we want to be in radians here, or degrees. Let's see, which one did they ask for? It's always better to read your directions because sometimes they want degrees. And this one does say 0 to 360, so yes, we are doing degrees, so that's nice. So we're going to leave this in degrees, and we're going to do the inverse of sine. Now that gives me a theta of 43.220 because it says we're supposed to go to 3 decimal places. So theta of approximately 43.220 if we round up to 3 decimal places. Okay, and that would be in degrees. Now let's think about what that actually says. So here is 43.220 degrees. Okay, this is all science teachers are crazy. There is another place where sine can have this positive ratio. Remember, this came out as a positive fraction when we checked it. And that other place is in quadrant 2, where sine is also positive. So there's also a 43.220 degrees here. To find that entire angle, though, because we want to report it from 0 to 360, we would do 180 minus that. So we're actually going to get two answers from this specific part. So 180 minus the 43.220, that's 136,780. So those are the two angles that we get from this first part. So we're going to go ahead and circle those. Now there's also two we're going to get here. Now we need to make sure if this is positive or negative, because if this is a positive ratio, your two answers have to be in 1 and 2 again. They would just be slightly different angles. If it's a negative ratio for sine, they're going to end up in quads 3 and 4. So let's just double check what that was. So 5 minus 2 times 22 as a square root, and then hit enter. Oh, that's not right. Sorry, it was keeping the stuff I did before. 5 minus 2 times 22 square root. Enter, and then divided by 2. So this time it's a negative. So because this is a negative ratio, and that doesn't look right. And then hit enter, and then divided by, because that's not showing up between -1 and 1. Let me do the 22 first. So 22 square root times 2, and then make that negative, add that to 5. Yep, this one's actually no solutions for this part if it comes out like that. Yeah, because this is actually negative 2.19 in here, and that is not between -1 to 1. So hang on just a second, because I believe they gave answers for this one. Oh, I know what it is. I just caught it. When I was trying to make more room, that looked like a 2 and it's a 21, because the 1 got erased off when I started moving the line down. Okay, this one is good. Sorry. We needed a 21 on the bottom, not a 2. So 5 minus 2 times the square root of 22, and then we're dividing that by 21. I knew that was something didn't look right. Yep. So this is a negative. This is a negative ratio. So we want to, at least I always mark that so I know this one was a positive ratio. This one's a negative ratio. And that's important for what quadrants you place your answer in. So now that we've got this decimal, we want to take the inverse sine of it in degrees, and that's negative 12.041. Now, that is a theta, but that's going to be a reference angle, because remember, sine inverse gives us this in negative for this quadrant. So this is a reference angle of 12.041, but we want to know what the actual angle is all the way around. So we need to do 360 minus that. And because there's also a negative ratio for this part of sine, there's going to be another answer with the same reference angle over here. So this one will be 180 minus the 12.041. So let's go ahead and work those out. 360 minus 12.041 gives me 347.9 or 0.95. I can't talk. 0.959. So 347.959 degrees. So there's another theta. And then this one would be 180, not minus, sorry, plus, because we're beyond the 180 degrees, plus the 12.041. So it's 192.041. Okay. So remember, whatever this sign inside is for that ratio, if it's a positive fraction or a negative fraction overall, you have to work that decimal out. That will help you know what quadrants you should be drawing your pictures in. Okay, so let's look at 37. This one's a cosine one. It's might be factorable here. 3 times 5 is 15. Factors of 15 that equal 8 is 3 and 5. Yeah, we can factor this one. So I'm going to go ahead and factor one just so we can do one that's not quadratic formula. So this would be 3 cosine squared theta plus, remember we expand the middle, so a 3 cosine theta plus a 5 cosine theta is the 8 plus the 5 equals 0. You can also do quadratic formula if you want. I'm going to pull a 3 cosine theta out of the first pair. That leaves me with cosine theta plus 1. I'm going to pull a plus 5 out of the second pair. That also leaves me with a cosine theta plus 1, and then this is equal to 0. Cosine theta plus 1 is the match, and 3 cosine theta plus 5 is the other piece, just like factoring by grouping. So cosine theta equals -1, and cosine theta equals subtract 5 and divide by 3. Now this one right here does not produce solutions, because the ratio for cosines are always supposed to be between, it's not between -1 to 1. -5.3 is actually -1.6 repeating or something like that, so it's too small. It's not between the -1 to 1. This one is a very specific case. Cosine is -1, that means your x is -1. That only occurs at one point. So since they want this in degrees, that theta is 180 degrees. So that's a singular solution. There's no other place where x is -1 on the unit circle. So that's the only solution. And then that leads us to our very last problem on the review. Woohoo! So this one, I'm not sure if it's factorable or not. We can double check real quick. 2 times -24 is -48. 1 and 48, 2 and 24, 3 and 16. Yes, this one is factorable, so I'm going to factor it with a -3 and a +16 will make the 13 in the middle. So 2 tan, and again, you could use quadratic formula if you want. So 2 tan squared theta, let's put the 16 first, plus 16 tan theta minus 3 tan theta minus 24 equals 0. Pull a 2 tan theta out of the first pair. That would leave me with tan theta plus 8. Pull out a -3 out of the second pair, since it leads with a negative. That would also make that tan theta plus 8. That means we have a 2 tan theta minus 3 and a tan theta plus 8 equal to 0. So tan theta equals 3/2, or tan theta equals -8. Tan can have any real number as its ratio. Remember, the reason for that is when you talk about tangent, remember it does this. It goes from -infinity to infinity up the y range. So it's possible to have any y value, which means the inverse can have any x value. So this is different than sine and cosine, which have the waves and they're bounded. So we can use our inverse button. So tan inverse of 3/2 and tan inverse of -8, sorry. So let's do that on our calculator. So 3 divided by 2, then take the inverse tan. We're in degrees still, like we're supposed to be. That's a theta of 56.310 if we round up. And this one will be -8 inverse tan. It's -82.875. Okay, so we need to place those both on the quadrants that they're correctly on and then find the matching quadrant answer. And remember, for the negative one, we will need to report it as a positive angle between 0 and 360. So for this first one, remember tan inverse is in, remember, quads 1 or 4. This would be in quad 1. So that's 56.310. All science teachers are crazy. That means the other angle for this pair is where tangent is, again, positive 3/2, which will be down here. And that guy will be 180 plus that. And so we have, this is one of my answers because it is the actual angle. This one would be 180 plus the 56.310. So that is 236,310. Since we're rounding to 3 decimal places, so that's the 2 angles from this part. This one would be, remember, in the negative part of the tan inverse, which is down here. So negative 82.875. Tan is also negative in quad 2. So this is also 82.875. This one we would do 180 minus the angle. This one we would do 360 minus the angle to figure out our reference or our actual angles between 0 and 360. So 180 minus 82.875 is 97,125. That's the one from quad 2. And the one in quad 4 is 360 minus 82.875, which is 277,125. Now I went through that pretty quick, so I'm going to double check it with the answer key. Everything looks good. So yeah, with these, with the tan, you just don't have to realize there's no restriction on that ratio on the other side. It doesn't have to be between -1 and 1, but if it's cosine or sine, it does have to be. And that's the end of all of the review. So hopefully with the review you had with my sub today, plus this, you'll be comfortable. But remember, you can always email me, come visit me during office hours. I plan on returning to work tomorrow. I'm well enough to, so I will see you guys either tomorrow or Thursday, whichever comes first. So whichever I see you. So be good, study hard, and I'll talk to you on Thursday.